All right, so the section 9.1 notes are involving exponential functions. So we're talking about exponential growth and decay situations. Now, this is really it's a pre-calc topic, but you'll see in a few moments why we need to talk about it in calculus. All right, so there's a couple statements that we want to make sure we understand. If we say y varies directly as x, y is directly proportional to x, then we would say that y is equal to kx, where k is some constant multiplied by x. So this is just linear, possibly. All right, and then we could also say y varies inversely as x. Y is inversely proportional to x. And that would be something like, y is equal to k over x or whatever, where k is some constant. All right. Now, what we're going to be doing is we're going to be talking about it in a calculus setting where we say something like the derivative of y, dy dx, varies directly as x, like so, kx. Now, if this was the case, then you would be able to multiply by dx, and you could say that dy is equal to kx dx. And then you would be able to integrate both sides, and then you would get that y is equal to kx squared over 2 plus c, right? Solving a differential equation, what we talked about in Unit 6. And so then you would see that, okay, well, if we say that the derivative of y varies directly as x, then really all we're saying is that the original function is some sort of a quadratic here, all right? But now, the statement that you're more likely to hear something like this is you're more likely to hear, like the derivative of y with respect to x varies directly as y does. So dy dx is equal to ky. Now, if we multiply by dx, we get dy equals ky dx. Now we have a problem because the y is with the dx. And so that's what we're going to be talking about today, and that's why it relates to calculus. But all of the homework questions and example questions are actually just pre-calc questions. All right, so let's read this. All right, so it says let y equal the size of the population at time t. Assume that y is greater than 0. Find an equation for y with the initial condition that when t is 0, y is y sub 0. dy dt equals k times y. So that's what we were talking about a minute ago. K is some constant that we don't know. It's unspecified, but we don't need to know it. So now, how would I solve this differential equation? So of course, we multiply by dt. So we get dy is ky dt. And just like we mentioned on the last slide, we can't deal with the y dt here, so we have to divide by y. So I get that dy is equal to, dy divided by y is equal to k dt. All right, so now we have actually separated the variables, the y and the t. Remember, k is not a variable. It's an unspecified constant. All right, so now I'm ready to integrate both sides. So I integrate dy over y, and I integrate k dt. All right, so now integral of dy over y. Now remember, dy over y is really like the integral of 1 over y dy. And, well, k is a constant, so you could bring that out. K times the integral of dt. All right, so now what is the integral of 1 over y dy? This is a memorization quiz rule. That is the natural log of the absolute value of y, right, plus c, but we're going to add the c in on the right side. So then I get k times the integral of dt. That would just be t plus c. So the natural log of y equals kt plus c. But now our goal is to solve for y. All right, so what is y? Well, before I do that, I want to solve for c. So I'm given that when t is 0, y equals y sub 0. So the natural log of the absolute value of y sub 0 is equal to k times 0 plus c. All right, so k times 0 is, of course, 0. So c is the natural log of the absolute value of y sub 0, but y sub 0, well, you're told that y is always positive, so the absolute value is not necessary. So c is the natural log of y sub 0. All right, so now let's head up here. We now know that the natural log of the absolute value of y is equal to k t plus the natural log of y sub 0. All right, so now I want to solve for y. All right, so first of all, how do I get rid of the natural log? All right, so you should recall this from pre-calc. The way to get rid of a natural log is to do the operation that is the inverse of the natural log. That would be the exponential base e. So we're going to exponentiate each side. So I have e to the natural log of the absolute value of y equals e to the kt plus the natural log of y sub 0. Remember, you're exponentiating the entire right side here. So you can't exponentiate each thing individually. You can't say like e to the kt plus e to the natural log of y sub 0. That is unacceptable. That is mathematically incorrect. All right, so now on the left side, e to the natural log of the absolute value of y, e to the natural log, those are inverse operations, so they cancel out, so I'm left with the absolute value of y, equals e to the kt plus the natural log of y sub 0. Now, if you have kt plus the natural log of y sub 0, you could rewrite it as e to the kt times e to the natural log of y sub 0. So then on the right side, you can simplify e to the natural log of y sub 0. You can reduce the e to the natural log, and you get that the absolute value of y is equal to e to the kt times y sub 0. But we would tend to put the y sub 0 in front, so we get y sub 0 times e to the kt. Now, I have the absolute value of y, but we were told that y is always positive. But what if it wasn't? Then I would actually have to have y equals, well, how do I get rid of the absolute value? I put a plus or minus y sub 0 e to the kt. Now, in this particular problem, we would just say, well, it's the positive because y is always positive. So y sub 0 e to the kt. Now, you should recognize this formula. I've used different variables on purpose, but what you might recall this formula is the a equals p times e to the rt. Remember, the a stands for like the amount after a certain amount of time. P represents the principal value. E to the rt, r is the rate of increase or decrease, and t is time. So this is actually the formula that we just developed through this situation. So when does the PERT formula apply? Well, when a particular population's rate of change, so dy dt, is directly proportional to the current amount of the population. So in this case, like y represents the population. So the rate of change of the population is directly proportional to the current population. So that's how population grows. What do we say? We say that the population is growing by 3%. 3% of what? Of the current population. So that's what we're going to be dealing with. All right, so it says in 1970 there were 203.3 million people in the U.S. In 1980 there were 226.5 million people in the U.S. Assume the population is growing at a rate proportional to the size of the population. So this statement, assume the population is growing at a rate proportional to the size of the population. So that is telling you that the a equals p times e to the rt applies. Now, you don't have to redo that differential equation each time. We are simply doing these as pre-calc questions, understanding that this formula applies. So, find a formula for the number of people in the U.S. T years after 1970. All right, so that means the amount after 10 years was 226.5, and that equals the principal amount, 203.3, times e to the r, which we don't know the rate, times time. 10 years elapsed from 1970 to 1980. And so what we want to do is we want to solve for r. So I divide by 203.3. So 226.5 divided by 203.3 equals e to the r times 10. How do I get rid of the e? I take the natural log. So the natural log of 226.5 divided by 203.3 equals, if I take the natural log of e to the r times 10, I just get r times 10. And so r is the natural log of 226.5 divided by 203.3, all divided by 10. So that's r. Now, you should be able to do this calculation, of course, all right, but that is a secondary to the actual algebra that takes place. And so if I do the calculation here, okay, and you should try this as well, I get approximately 0.01081. Now, I'm actually going to use the regular calculated value when I actually do a calculation. All right, and so what am I going to say? I'm going to say, well, R is this, but my formula, right, it says a formula for the number of people in the U.S. 2 years after 1970 is going to be A equals P 203.3 times e to the r, which I just solved, times t. And that is t years after 1970. All right, so find the population in the U.S. in 2011. All right, so 2011 is how many years since 1970? All right, so 41 years have elapsed. And so we're going to say, all right, well, A is 203.3 times e to the r times 41. Now remember, r is this calculated value here, so we're not going to type in 0.01081. We're actually going to use the calculated value. We're going to use like the answer function on our calculator, and we're going to calculate. So A is 203.3. You should be trying to do this calculation on your calculator as you're following along. E to the answer times 41. And so if I do that, I get approximately 316.631 what? Well, this units are million people. Right now, some people would say, well, you can't have a decimal for people. Well, yeah, you can, because this is 316.631. That would be 316,631,000. So you're really estimating to the nearest thousand. Sorry, not thousandth, the nearest thousand people when you're writing it like that. All right, so really just a pre-calc question. So our additional examples are basically the same thing. All right, so in 1970, they were the same exact thing. But now it says, when will the population first reach 400 million people? So what does that mean? That means that A is 400. So A is 400, 203.3 equals e to the r, the same r that we had from before, times time. The question is when. So we want to know the amount of time it's going to take. All right, so once again, do the algebra. We divide by 203.3, so 400 divided by 203.3 equals e to the rt. Get rid of the e by taking the natural log. So the natural log of 400 divided by 203.3 equals r times t. And now remember, we're trying to solve for t, so we divide by r. Remember, r was that value that we got earlier, 203.3. And then divided by r. So once again, we can do this calculation using our answer function. So we have r, so we're going to take the natural log of 400 divided by 203.3 and then divide by the previously calculated value. So we're going to get 629 what? Well, that would be years since 1970. And so what does that mean? It says when. And so if we take that value and we add it to 1970, we get sometime during the year 2032. Right now it's 2032.6289 or whatever. But remember, we're just saying like during that year. When? Well, during the year 2032. All right, how long will it take for the population to double? Well, this is actually pretty easy. Well, if it started at 203.3, then that means now it's 406.6, right? Equals e to the rt. But really, when I divide by 203.3, I just get 2, don't I? So 2 equals e to the rt. So it doesn't really matter how much you started with. It just matters that now we have double. All right, and so we're going to take the natural log of both sides. So the natural log of 2 equals Well, the natural log of e to the RT, or just RT. So t is equal to the natural log of 2 divided by r. And remember, r was that previously calculated value. And so we're going to take the natural log of 2 divided by the previous answer, which now gets us 64.143 years. Now, think about the question. How long will it take for the population to double? 64.143 years. So earlier, we should have answered like during the year 2032 because it said when, and now we need to answer 64.143 years because it says how long. All right, so once again, still just pre-calc questions. All right, so now same idea, but with an exponential decay situation. All right, so the decay of a radioactive substance obeys a similar law. Living substances contain a constant ratio of carbon-12 to carbon-14. When the object dies, the amount of carbon-12 remains the same, but the amount of carbon-14 drops at a rate proportional to the amount left. So rate proportional to the amount left, right? Remember, rate means derivative. Proportional to the amount left, that would be the current amount. So half of carbon-14 decays every 5,700 years. Determine the value of K, or R in this case, right, of carbon-14. All right, so what does that mean? Well, that means that however much you started with, let's say you started with 100%, right, then that means you have 50% remaining after 5,700 years. So you'd say 50% equals 100% e to the r, or k, times 5,700. All right, and so now we want to solve for r, or k, or whatever. All right, so I divide by 100. But if I take 50 divided by 100, I just get 1/2. So it doesn't really matter how much you started with. It matters that once you divide, you have 1/2. So 1/2 equals e to the r times 5,700. And so, just like earlier, I'm going to take the natural log of 1/2 equals r times 5,700, and then I'm going to divide. So r is the natural log of 1/2 divided by 5,700. So once again, you should calculate this value, but in all of our later questions involving this, we're just going to use this exact value, natural log of 1/2 divided by 5,700. All right, so when I do that, okay, remember, on your calculator, you get negative 1.216, and then you have the e negative 4. What does that mean? Remember, times 10 to the negative 4th, or that really means negative point. Remember, you're moving the decimal 4 places, so 0.0001216. All right, now, why is it negative? Well, remember, the amount of carbon-14 is decreasing, so its rate should be negative. So if you don't get a negative here, then you've done something wrong. All right, so now it says wood in an ancient campfire has 30% of the carbon-14 found in living trees. How long ago was the wood cut? So when, how long ago did the tree die? All right, so we start off, well, now we have 30%. That's the amount that we have. We started with 100% times e to the r times time. Now, t is what we want to know because that answers the how long. So we divide by 100. Of course, we get 0.3 equals e to the r times time. And so natural log of 0.3 equals r times time. So time equals the natural log of 0.3 divided by r. Now, r is the value that we just used here, but don't type in the negative 0.000116. Use the natural log of 1/2 divided by 5,700. So natural log of 0.3 divided by the previous answer gives us about 9,900.704 years. Now it says how long ago. So 9,900,704 years ago. Right? Now, does this answer make sense? It takes 5,700 years to become half. So in 5,700 years, 100% would become 50%. And then in another 5,700 years, 50% would become 25%, 30% slightly more, so it would be less, of course, than 5,700 times 2. So makes sense. All right. So all of your homework questions are pre-calc questions with the underlying calculus that we can use, the A equals PERT formula.